Welcome. In this video, we're going to use the graph of f of x below to estimate the value of each of these derivatives. That is, we're going to estimate the value of the slope of the tangent line here at -2. So if this is -2 and this is our tangent line, we're going to use the techniques we learned back in algebra to kind of count the rise over the run and figure out what the slope is. And we're going to do that for all of these points. Using that information, we're going to graph an estimate of what we think the first derivative of this function will look like. In order to keep our work more organized, let's begin with the table. So x and f prime of x. Okay, so there's our table of values, which I only split into two just to keep it visible on this screen. So I'm going to compute this slope, this slope, this slope, and this slope, and then you're going to have to pause your video and work out the remaining slopes at these points. Okay, so let's begin here at -2. So at this point, you need a ruler. So take your ruler out, and when you're using your ruler, you want to drag it as closely as you can. And be sure to place your ruler in a spot so that it mimics the slope of the tangent line. And so here it is. There's my line. And now let's estimate the rise over the run. And let's look up one step. And let's estimate just the distance traveled along this horizontal change. So this distance, delta x, versus the vertical distance. So in order to get from this point all the way to this point, how high up, that is delta y, how high up have we gone? So what is this vertical distance? That is, what's the change in y for every 1 unit of change in x? And here I have a whole box, and this looks like a little more than half and a little less than half. So I'm going to estimate that the slope of this line, that is the rise here, the rise, the delta y divided by the delta x, I'm estimating that the rise is 2 over a run of 1. That would give me a slope of 2. So let's do this again. And you should be getting your ruler, and if you've ever ridden a roller coaster, imagine the roller coaster is your ruler along this curve. And so the roller coaster is going to match, that is the roller coaster car you're on, is going to match the slope of this curve of this roller coaster at any point. So if you're measuring the slope at x equals -1, the roller coaster car is going to have the same slope. So that's kind of what your ruler should look like at that point. Okay, so here's the estimate that I have for this tangent line at x equals -1, and let's do the same thing. So that is over the point, over the change of 1 unit here, so delta x equals 1, so the change of x equals 1, we're going to figure out how much y has changed from here to here. So what is this vertical distance? And this is a pretty small vertical distance. If you notice, I've changed about this amount. So this is my vertical change delta y right there. So that tiny vertical change is delta y. And this little vertical distance looks like it's almost about 1/3, not quite, but it's a little bigger than 1/4. So I'm going to estimate the slope of this tangent line is 0.3. Now, right here, I want to stress that when you estimated this, you might have thought it was 0.25, or you might have thought it was 0.35, as long as you're fairly close to this value. If you estimated that it's negative anything, that can't be correct, since clearly this line is going uphill. If you estimated that the slope of this line is larger than this slope here, that also can't be possible because originally our ruler was in this direction and now it isn't as steep, so it has to be smaller. So remember, these are all just estimates, so your estimate can vary from person to person visually, especially because we can't really zoom in on this grid. It is stuck at that point of view. So we are just kind of eyeballing what we think the slope of these tangent lines are. Okay, so I'm going to do 2 more. I'm going to estimate the slope for you at 5 and at 6, and then you're going to finish the rest of these independently. So here's x equals 5, and 4, 3, 2, 1. So it's definitely x equals 5 here. And so we want to place our ruler right along here so that it matches the slope of our tangent line. And in fact, it's matching the slope of the line. Since it's very, very close to the line, the tangent and the line have the same slope by definition. All right, so there is my estimate for the tangent line here at this point. And of course, that's at x equals 5. And it's definitely still positive, so it's still an uphill slope here. When you're doing this on your own and you're, say, here at 2, your line, your ruler is going to be downhill. So this one should definitely be a negative value. That's a hint, a negative number. But for now, this one's still positive. And so let's measure again. For one change in x, that's this distance, this horizontal distance here, how much has the y changed? Well, we've gone from here to here. And that looks like it's about 1, since if you notice, this is a little bit above, y equals 2, and this is a little bit above y equals 3. So I'm going to estimate that that change is 1. And again, I want to stress, you might have estimated that it's 0.9 or 1.1. Again, as long as you're fairly close, as long as you didn't write that this line has a negative slope, or that you didn't write this slope of this line is, say, larger than the slope of this line, which when I draw both of them, it's clear that this has a larger slope than this slope. So as long as you're fairly close to this value, you're good. All right, let's do one more together. That is, let's estimate the slope of this line at x equals 6. And clearly it will not be the same line, because here's x equals 6, and this line does not have the same slope. It looks like this slope might actually be a little bit steeper here. To help us visualize that, I'm going to leave this line at this point and draw my next tangent line in a slightly different color. So get your ruler out, and remember, your ruler is the roller coaster car that you're writing, so your ruler is going to be aligned and have the same slope as the actual roller coaster frame at that point. There's my estimate for the tangent line at x equals 6 right here. X equals 6, and this green line shares the same slope as the blue curve at x equals 6. And now we're going to visually try to figure out what this value is. I left the previous tangent line, and this is the line tangent at x equals 5, just so we could clearly see it's definitely larger than this line. That is, this line is more steep, so its slope has to be larger than 1. And let's verify this. There's 1 unit of change, delta x equals 1. We started here along our green line, and we end here. So what is this vertical distance? I would guess that this change, delta y, I would guess that is about 1.1, 1.2. So I'm just going to write 1.1. That looks like a little safer bet, actually. 1.15. I'll split the difference there. Your estimate should be fairly close. Now that I have my estimate for delta y, I can say that my estimate for the slope of this line is the change in y over the change in x, which is 1.15 over 1, or just 1.15. So go ahead and write this on your table. And now take the time, pause the video, and try to estimate the slope of the tangent line at all these other values. So that means you're going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9 more tangent lines at different places, and estimate what you think the slope is at all of those values. All right, now that you've paused your video, you should have filled in your table as follows. I want to reiterate that your numbers do not need to match mine exactly. They should be fairly close. So let's take a look at what's happening here. So remember, the tangent line is like the roller coaster car, and the curve is the roller coaster frame. So the tangent line, that is the roller coaster car, is going to have the same slope as the roller coaster frame as you're writing on the roller coaster. And here at 0, you notice we had a peak somewhere between -1 and 0. There was a peak where you're all the way at the top of the roller coaster and you're anticipating that drop. And that drop is already beginning, but it isn't as steep as, say, this, which should be a slope of -1. So this is how I estimated -0.4. And then at 1, the drop has already started happening a little more, but again, it isn't as steep as this. And then here at +2, the slope is starting to level off again. So you're going downhill, downhill, and then you're leveling off. And then here at 3, you're flat again. And you're going uphill on the roller coaster. So as long as these are negative, and then between here and here, you should have positive slopes. At 8, you might have thought this is 0 and flat. I estimated that the flat spot was right about here, a little to the right of 8, so I put a positive slope that is really close to 0 at 8. But then, of course, after 9, the slope of this roller coaster car is downhill because this is the big peak at the end, right before the ride finishes, where you have that giant drop and they take your picture making a funny face on the roller coaster. So that's where you are right there. And so this is definitely a very negative slope around here. So this is the largest negative, that is the most negative number here. Okay, so now with this information, let's go ahead and on our same graph, let's sketch what f prime of x will look like. And I'm going to sketch this in red. So take a moment, and at -2, say you're going to plot +2. At -1, you're going to plot about 1/3. So please fill in the rest of these points. All right, I went ahead and plotted several of these points. Now connect the dots. Please notice that here at -10, since this only went down to -3, I kind of put this dot here above where I thought -4 is. So you should have one dot that goes below your graph. So this red graph represents the derivative of f of x. So the red graph is y equals f prime of x. And the derivative of this graph can tell us the slope of the tangent line at any given point within its domain. For example, so this red graph tells us if I want to estimate what the slope of this line here is at 1/2, I look down at the value and I think, that looks like it's not quite -1/2. I'm going to say it's somewhere between -0.4 and -0.5, so maybe it's -0.45 would be the slope of the tangent line here at x equals 0.5. So that's what this red graph is telling you. And if you notice, it crosses the x-axis 1, 2, 3 times. These correspond to wherever we have this flat spot. Because remember, if you're riding the roller coaster, when you get to the flat spots, that means you're just horizontal with the ground. So you're not going uphill on the roller coaster, you're not going downhill. And that happens 3 times. The slope of the tangent line at these flat points has to be 0, since this slope matches the slope of the ground that you're on, in essence. And so here, here, and here, these 3 intersections of our first derivative match up with these peaks and this valley. So I hope from this video you'll take that it is really doable to just sketch the derivative of any graph. All it does, it just takes a little bit of patience and drawing lots of tangent lines and working out their slopes individually, but it can be done. I hope this video was helpful.